principles behind trigonometric functions. First, we shall discuss about right triangle. A right triangle is a triangle where one of the internal angles is 90 degrees. So this is an example of a right triangle. This is 90 degrees. So for right triangles, the ratio of the sides are always equal. So for a 60 by 30 by 90 degrees, this is the ratio. So if this is 1 unit length, the hypotenuse will always be twice as this unit length, and this side will always be approximately 1.732 times of this length. So now that we have the ratio for any right triangle that has a 60-degree angle, we can always now know the rest of the sides if we know one of the sides. So if this is the side, this is 10 meters. So if we want to get this side, if you will see from here, it will be times 2. So this 10 meters, we multiply it by 2, we will get the hypotenuse, which is 20 meters. Now for this one, if you will compare this one to here, this one is multiplied by 10 and it becomes 10. So we multiply this one by 10 as well. So this becomes 17.32 meters. So that's the how you solve for right triangles. So they have made names on these sides. So for example, if you have the angle here, the side close to the angle, which is not the hypotenuse, this is called the adjacent side. Adjacent side. And the one opposite this angle, this is called the opposite side. And this one is the hypotenuse of the triangle. Hypotenuse, the longest side of a right triangle, is the hypotenuse. Now, if we can make ratios of the 60 degrees angle, for example, let's see the ratio of the opposite over the hypotenuse. So opposite over hypotenuse, the ratio would be 1.732 over the hypotenuse, which is 2. So the ratio of the opposite over hypotenuse would be 0.866. Now the ratio of the adjacent side over the hypotenuse, adjacent will be, this is 1 over 2. 1 divided by 2 is 0.5. So let's see the ratio of the opposite over the adjacent. Opposite over adjacent will be 1.732 divided by 1, or 1.732. Now we can use these ratios to solve for the sides of the right triangle. For example, we have a right triangle here, 60 degrees. We know that the hypotenuse is 8 meters, but we don't know the adjacent side. So we look for here this ratio, adjacent over hypotenuse. Adjacent. So this is the adjacent over hypotenuse. We can use this ratio to get this side. So the adjacent over hypotenuse is 0.5 is equal to adjacent x over 8 meters hypotenuse. Solving for x, we multiply both sides by 8 meters. 8 meters, we have x equal to 4 meters. So this will be 4 meters. Now, mathematicians have tabulated the ratios for every angle of a right triangle, every part angle, every degree, every part degree of a right triangle. And they have put a name on these ratios. So opposite over hypotenuse, this ratio, they call it the sine function. The ratio of the adjacent over hypotenuse, they call it the cosine function. And the ratio of the opposite over adjacent, they call it the tangent function. Now, so for example, we have another right triangle, and the angle here is 50 degrees. And we know that the hypotenuse is 12 inches. And we would like to know the opposite. So this ratio is opposite and hypotenuse. If we look at these ratios, it will be this one, sine. So we need to get sine of 50 degrees, this ratio, and then we write this ratio, opposite over hypotenuse. Now, if we get a calculator, we can get the ratio of sine 50 degrees. Sine of 50 degrees is equal to 0.766 something. So we can write in here 0.766 is equal to x over 12 inches. So we multiply 12 inches on both sides. This will cancel out. X will be 9.192 inches. So this x is 9.192 inches. So that's how you solve for the size of a right triangle using the trigonometric functions.